How China is building the world's largest dam in Africa. China is building the largest power station in human history on African soil, and it will produce nearly double the output of the Three Gorges Dam, currently the biggest power station ever built. To put that in perspective, Three Gorges alone powers more people than the entire United States has citizens. Grand Inga will do twice that. You heard that right. And that is just the beginning. Because the craziest part isn't the size, it's what this dam actually means for the next 100 years of African history and who gets to control it. If that already has your attention, hit a quick like and subscribe so you don't miss the next one. By the end of this video, you are going to understand exactly how China is quietly becoming the energy backbone of an entire continent. Here is where it starts, with a record that was never supposed to be broken. The benchmark you thought was unbeatable. Picture the biggest thing you have ever built. Maybe it was furniture, maybe it was a wall. Now scale that up by every order of magnitude you can imagine, and you still won't be close to the Three Gorges Dam. The Three Gorges Dam sits on the Yangtze River in central China. It is 600 feet tall. It stretches over a mile across. And it holds back so much water that when it filled up, the weight of that reservoir physically slowed the Earth's rotation by a measurable amount. Not a metaphor. The planet actually moved differently because of this structure. It generates 22,500 megawatts of electricity. To anchor that number, that is enough to power a country the size of Australia continuously, around the clock. It took nearly 2 decades to complete and cost over $60 billion. When it was finished, engineers around the world agreed on one thing: nothing would ever surpass it. They were wrong. Now here is the part that reframes everything you just heard. Three Gorges wasn't the ceiling, it was the blueprint. Because on the other side of the world, on a river most people couldn't point to on a map, engineers have designed a power station that will produce 40,000 megawatts. That is nearly double what Three Gorges produces. Not an incremental improvement, not a marginal upgrade. Almost twice the output of the largest power station ever built from a single site. That site is Grand Inga, and it sits on the Congo River. The Congo is not a river most people think about when they think about power, but they should. It is the second largest river on Earth by volume. Every single second, 41,000 cubic meters of water move through it. To put that in terms, you can imagine every bathtub in a mid-sized city being emptied simultaneously. And at one specific point along that river, a place called Inga Falls, the Congo drops sharply through a narrow geological channel. The water accelerates, the pressure concentrates. And what you get is a natural energy trap so powerful that this single location holds nearly 1/3 of Africa's entire installed electricity capacity, untouched, waiting. Grand Inga isn't just the largest dam ever attempted. It is arguably the most logical one ever conceived because the geography did most of the work before a single engineer arrived. But understanding why this site is special is only half the story. The other half is understanding what China brought to the table that no one else could. And that is where this gets genuinely extraordinary. The river that was always going to change everything. You have probably never thought about the Congo River. Most people haven't. It doesn't carry the same cultural weight as the Nile. It doesn't appear in the same documentaries as the Amazon. But in terms of raw, concentrated energy potential, it is the most extraordinary river on Earth. Here is why. The Congo is the deepest river in the world. In some stretches, it plunges over 700 feet down. That is deeper than a 60-story building is tall, submerged entirely below the water's surface. And unlike most major rivers that fan out and slow down as they approach the sea, the Congo gets forced through a series of narrow gorges near its mouth. The water doesn't spread, it accelerates. At Inga Falls, that acceleration becomes something engineers describe in language that sounds closer to awe than technical analysis. The river drops over 300 feet across a relatively short stretch. It doesn't do this gently. It does it violently, through a channel carved by millions of years of geological pressure. The result is a hydraulic condition so extreme that the energy density at this single site is almost without parallel anywhere on the planet. Now here is the detail that puts everything into perspective. Most large dam projects spend the majority of their budget doing one thing: creating elevation. You build a wall, you flood a valley, you manufacture the height difference that generates power. It costs billions. It displaces communities. It takes decades. At Inga Falls, nature already built the elevation. The river drops 300 feet, whether you build there or not. Grand Inga doesn't manufacture that power. It intercepts it. And the numbers that follow from that are staggering. This single location on its own holds the theoretical capacity to generate nearly 1/3 of Africa's entire current installed electricity capacity. Africa's total, from one site, on one river, in one country. To understand what that means in human terms, 600 million people on the African continent currently have no reliable access to electricity. 600 million. That is nearly double the entire population of the United States living without a stable power source. Grand Inga, fully built, could change that equation permanently. But a river with extraordinary energy potential is not a power station. It is just a geological fact. Turning that fact into 40,000 megawatts requires engineering decisions that have never been made before, and an approach to dam building that breaks almost every assumption you have about how these structures work. The dam that isn't really a dam. When most people picture a dam, they picture a wall. A massive concrete barrier stretching across a river, holding back an artificial lake so enormous it reshapes the landscape around it. That is what Three Gorges looks like. That is what the Hoover Dam looks like. That mental image wall, reservoir, flooded valley, is what the word dam has meant for a century. Grand Inga throws that image out completely. Here is what most people never think about when they picture a dam. The reservoir isn't the point. The height difference is the point. The reservoir only exists because you need to create an elevation gap between the water's entry and exit so that gravity can do the work of spinning a turbine. The wall is just the method. At Inga Falls, the method is already built into the landscape. So instead of constructing a wall across the full width of the Congo River and flooding thousands of square miles of rainforest the way Three Gorges flooded an area the size of Singapore permanently, displacing over 1 million people, engineers at Grand Inga are planning something fundamentally different. They will divert a controlled portion of the river's flow through a system of channels and tunnels. That water will be directed at high velocity toward turbines. The natural elevation drop at Inga Falls provides all the hydraulic pressure needed. You are not storing the energy. You are channeling it. The force comes from the flow, not the volume behind a wall. And the turbines themselves are where the engineering becomes genuinely unprecedented. Individual units at Grand Inga are projected to exceed 700 megawatts each. 700 megawatts from a single turbine. Most countries on the African continent operate national grids smaller than that. A single spinning unit at Grand Inga would outpower an entire nation's electricity system. These turbines won't sit in open air. They will be housed in underground powerhouses carved directly into the rock. This isn't just for aesthetics. Underground placement protects against flooding, stabilizes temperature, improves structural integrity, and increases long-term operational efficiency. The mountain becomes part of the machine. Now here is the part that blows people's minds. Grand Inga, at full capacity, would do all of this without creating the kind of environmental and humanitarian catastrophe that has defined large dam projects for generations. That does not make it simple. It does not make it cheap. But it makes it categorically different from every large-scale hydroelectric project ever attempted. The engineering, in other words, is solved, at least on paper. What wasn't solved was who on earth had the capacity, the capital, and the institutional nerve to actually build it. That answer, it turns out, only pointed in one direction. Why only one country could pull this off? There is a specific kind of knowledge that only comes from having already done the impossible. Not the knowledge you find in textbooks, not the kind you acquire in a classroom or inherit from a consultant's report. The kind that lives in the hands and decisions of the people who built something that had never been built before and watched it work. China has that knowledge, and for Grand Inga, it is the only country that does. The China Three Gorges Corporation built the world's largest dam, not managed it, not financed it after someone else constructed it. Built it from the engineering decisions made before the first concrete was poured to the operational systems running it today. That institutional memory does not transfer easily. You cannot hire it. You cannot import it from a country that has never attempted anything at this scale. The Power Construction Corporation of China, known as Power China, operates at a similar level. It is one of the largest engineering and construction organizations in the world. It has built hydroelectric projects across Asia, Africa, and South America. It understands how to move equipment into remote environments, how to manage a workforce of tens of thousands across a decade-long build, and how to coordinate supply chains that stretch across multiple continents simultaneously. Here is what makes this incredibly exciting and strategically important. China's involvement in Grand Inga isn't structured the way a typical construction contract works. Chinese firms are not showing up as hired hands who leave when the last turbine is installed. They are positioning themselves as lead partners in international consortia with financing structures that extend their role from construction through to long-term operation. That distinction matters enormously. When a country builds your power station and then helps finance it, the relationship does not end at the ribbon-cutting ceremony. It continues through every maintenance contract, every grid, expansion decision, every operational upgrade for the next several decades. China is not building a dam. China is building a permanent seat at the table of the Congo's energy future. And Beijing already has a specific piece of technology that makes this even more strategically coherent. China has built ultra-high voltage direct current transmission lines that move electricity over 3,000 miles across its own territory. 3,000 miles. That is roughly the distance from New York City to Los Angeles, moving power continuously at scale. That technology, already proven, already operational inside China, is exactly what you need to deliver 40,000 megawatts across the African continent to the countries that need it most. But here is the brutal catch. Generating 40,000 megawatts is only half the problem. What happens after the electricity leaves the turbine is a challenge so complex, it makes the dam itself look straightforward. The harder problem: moving 40,000 megawatts across a continent. Imagine filling the world's largest water tank, then realizing you have no pipes. That is roughly the situation Grand Inga creates the moment it begins generating power. 40,000 megawatts of electricity, nearly double the output of the largest power station ever built, flowing out of turbines in the Democratic Republic of Congo. And on the other side of that equation, a continent where most national electricity grids carry less than 1,000 megawatts total. 1,000. A single Grand Inga turbine unit would overwhelm the entire national grid of a typical African country. So the transmission challenge is not a footnote to the Grand Inga story. It is half the story. Moving electricity across long distances is not like moving water through a pipe. Standard alternating current transmission, the kind that powers most national grids, loses significant energy over long distances. It is simply not built for continental-scale delivery. The solution is high-voltage direct current transmission. HVDC lines carry electricity at extreme voltages across thousands of miles, with dramatically lower losses than conventional systems. China already operates HVDC corridors inside its own territory that stretch over 3,000 miles. To anchor that distance, 3,000 miles is roughly the width of the continental United States, coast to coast. China moves power across that distance continuously as a matter of routine infrastructure. That technology becomes the connective tissue for Grand Inga's ambitions. Transmission corridors stretching from the Congo northward toward Egypt and Nigeria, southward towards South Africa. South Africa, a country that has endured years of rolling blackouts, where businesses run on generators and households plan their days around scheduled outages, is one of the most committed potential anchor customers for Grand Inga's output. A stable, large-scale baseload supply from Inga would not just supplement South Africa's grid, it would restructure it. Here is what most people get wrong about this challenge. It is not purely an engineering problem, it is a political one. Delivering electricity across the African continent means routing transmission lines through multiple sovereign nations, each with its own grid standards, its own regulatory frameworks, its own political relationships, and its own ideas about who controls the infrastructure crossing its territory. Negotiating those corridors is, in some ways, harder than building the dam. And yet China's existing relationships across the continent, built through 2 decades of infrastructure investment, From roads and railways to ports and telecommunications, give it a diplomatic runway that no other nation currently possesses. The electricity, in theory, can move. The question of whether the politics will allow it to move is a different matter entirely, and that question has already derailed this project more than once. Because Grand Inga has a history. A long, complicated, and sometimes devastating history, and understanding it is the only way to understand why this time might actually be different. The graveyard of good intentions. Grand Inga is not a new idea. That is the part nobody talks about. The first serious engineering studies on the Congo River's potential at Inga Falls were conducted in the 1960s. Think about what the world looked like then. The Apollo program hadn't yet put a man on the moon. The internet didn't exist. And yet engineers were already standing at the edge of Inga Falls, looking at the water, running the numbers, and arriving at the same conclusion that engineers arrive at today, that this site is extraordinary, that the potential is almost without parallel, and that someone should build something here. That was over 60 years ago, and Grand Inga still isn't built. What exists at Inga today are two smaller predecessors, Inga 1 and Inga 2, constructed in the 1970s and 80s. Together, they have a combined capacity of around 1,775 megawatts. 1,775 megawatts sounds significant until you remember that Grand Inga is designed to produce 40,000. The existing dams are not a foundation for what's coming. They are a rounding error. And here is the detail that engineers don't want to admit. Both existing dams have spent significant portions of their operational lives running at a fraction of their designed capacity. Equipment failures, maintenance backlogs, funding shortfalls. The infrastructure that was supposed to prove Inga's potential has instead spent decades illustrating how difficult it is to sustain complex engineering in an environment defined by political instability and chronic underinvestment. The Democratic Republic of Congo is one of the most resource-rich nations on Earth. It holds vast reserves of cobalt, coltan, copper, and diamonds. Beneath its soil lies a catalog of materials the modern world depends on. And yet it consistently ranks among the lowest in global development indices. Decades of colonial extraction, followed by dictatorship, followed by civil conflict, followed by the kind of governance fragility that makes long-term infrastructure investment feel like a bet placed on a roulette wheel. That context is what killed the Grand Inga project not once, but repeatedly. The most significant blow came in 2016. The World Bank, which had been one of the project's key institutional backers, withdrew its support. Publicly, the reasons cited included governance concerns and questions about whether electricity generated at Grand Inga would actually reach the populations who needed it most, or whether it would be routed primarily to industrial mining operations and export markets while the Congolese population remained in the dark. Over 70% of the DRC's population has no access to reliable electricity. 70% of a country sitting on top of the most powerful undeveloped hydroelectric site in the world. Now here is the part that reframes the entire history you just heard. The World Bank's withdrawal didn't kill Grand Inga. It created a vacuum. And vacuums, in geopolitics, don't stay empty. They get filled by whoever is willing to move when everyone else steps back. China stepped forward. The World Bank re-entered cautiously in subsequent years, but the center of gravity had already shifted. The institutional momentum, the financing conversations, the engineering partnerships, they were now anchored in Beijing, not Washington or Brussels. And that shift, that quiet, decisive repositioning while Western institutions debated governance frameworks, is what transforms Grand Inga from an infrastructure story into something far more consequential. Because what flows out of those turbines when they finally spin isn't just electricity, and understanding what it actually is will change how you see every infrastructure deal China has made on this continent for the last 20 years. The power station that changes who holds the switch. Here is the part that makes Grand Inga bigger than a dam. If China helps build it, finance it, connect it, and keep it running for decades, then China is not just constructing a power station in the Congo. It is placing itself inside the nervous system of African development. Because electricity is not another resource. It is the resource that makes every other resource valuable. You can have cobalt under the ground, copper in the mountains, diamonds in the soil, and oil beneath the coast. But without reliable power, those materials leave as raw wealth and return as expensive finished products. The country that controls the energy behind processing, refining, manufacturing, and transport controls where the real value is created. That is why Grand Inga matters far beyond the Congo. 40,000 megawatts from one site would not simply add electricity to Africa's grid, it would change what entire economies can attempt. That is nearly double the output of the Three Gorges Dam, the largest power station ever built. You heard that right. One project in the Congo could make governments rethink their factories, mines, ports, railways, export routes, and long-term industrial plans. Now here is what most people miss. The real prize is not only the dam. The real prize is the system around it. The turbines matter, but so do the transmission lines, the substations, the financing, the maintenance contracts, the software balancing the grid, the engineers who return when something breaks, the companies that upgrade the equipment 20 years later. Whoever becomes essential to those pieces does not need to own the continent's resources. They only need to become the partner everyone must call when the lights flicker. Picture a city where every building depends on one underground cable. The person controlling that cable does not need to stand in every room. Their influence is already there. That is why Grand Inga is not just an African infrastructure story. It is a preview of how power will work in the next century. The old world was shaped by whoever controlled oil fields, shipping lanes, and military bases. The new one will be shaped by whoever controls electricity corridors, battery supply chains, rare minerals, and the infrastructure connecting them. China has spent years preparing for that world through roads, ports, railways, mines, telecom networks, and power projects. Not one deal, not one dam, a web. And Grand Inga could become its brightest node. For Africa, this is the opportunity and the danger. If it works, it could stabilize grids, reduce blackouts, power factories, support hospitals, and help turn raw resources into local industry. It could give millions of people something. Development reports have promised for generations, but rarely delivered, reliable electricity at transformative scale. But if the system makes one outside power too central, then the same project that lights up cities could create a new dependency. So when you hear that China is helping build the world's largest dam in Africa, do not picture concrete. Picture a switch. Then, picture a continent waiting to see whether that switch becomes a doorway to energy freedom or a lever someone else can hold. If this changed how you think about China's role in Africa, hit that like button and subscribe so you never miss what comes next. Now I want to hear from you in the comments. Is Grand Inga Africa's biggest chance at energy independence or the beginning of a new kind of dependency?